Alright, so we are going to be solving this combination circuit that is a combination of both a series and a parallel circuit with a voltage of 10, one resistor being 17 ohms, the second being 9 ohms, the third being 13 ohms, and the fourth being 11 ohms. So we are going to fill in our VIR chart with these values, so the 10 volts in the total volt section, and then the number of ohms in each resistance section. And after we fill out those values, we then have to combine these circuits and condense them to get our total resistance value. So the first one we want to combine would be R2 and R3 because they are part of a series circuit that we can then condense. So to get total resistance here, you just add the resistances. So that would be 9 ohms plus 13 ohms. And 9 plus 13 is 22, so this would be 22 ohms for the value of R23. Then we want to combine R23 and R4. So as we can see in this new combination circuit that I'm drawing here, we now have a parallel circuit with two resistors on each side. So to combine R23 and R4, we have to combine the reciprocal of the reciprocals. So that would basically mean we have to do the reciprocals of the resistance values. So that would be R23, so that'd be 1 over 22 plus 1 over 11 for R4, and that can be change the denominator into 1, it being 2 over 22, so it's 1 22nd plus 2 22nds, which comes out to being 3 22nds, which simplified is 7.33 ohms. So this value would be our total number of resistance for R234. Alright, so we can then, here I will show 9 plus 13, 22 ohms for R23, and then the combination of that plus our parallel circuit, 7.33 ohms. So to get our total resistance value, we then have to combine the total condensed circuit, so that would be 7.33 plus our first value, which is 17 ohms, so that would come out to being 24.33 ohms for our total resistance value. From here, we can then use Ohm's law, which tells us that voltage equals current times resistance. So to do that, we would then use a single-step algebraic equation and do 10 volts equals 24.33 ohms times the current. So we would do 10 divided by 24.33 to get our current value of 4.11 amps. So we can then plug in our 4.11 amps value into our VIR chart. And because current is consistent in a series circuit, we can also apply that 4.11 value to our first row with our first resistor because that continues in a series circuit. From here, we can then again use Ohm's law to find our voltage number. So we can do 4.11 times 17 ohms, which comes out to being about 6.987 volts. So we can plug in our 6.987 volts. And from here, we then have to deal with our condensed circuit again. So because voltage is constant in a parallel circuit, we can subtract 6.987 from our total 10 volts to get the amount of voltage that will be in our R4 circuit, which would be 3.013 volts. We can again use Ohm's law to divide 3.03 volts by 11 to get our current value, which is 0.274. So 0.274. And because current is added up to the total current, the sum of all the current is the total current in a parallel circuit, we know that 2 and 3 have to add up to 0.274, and they also have to be the same because current is constant in a series circuit, and R2 and R3 R in a series circuit. So we know that we have to divide 0.274 divided by 2, which would be 0.137. And that would be 0.137 would be our amps value for both R2 and R3. And to finish out our VIR chart, we can then use Ohm's law for both values and do 0.137 times 13 and 0.137 times 9, which would be 1.233 volts, and 0.137 times 13 is 1.781 volts. And that is our finished solved circuit with our finished VIR chart. Thanks for watching.